Hello, Mark. How are you?
Hello, Helen. I am very pleased to be able to be here and speak with you.
Welcome to the TH conference in Beijing.
I wish I could be there in person.
So, artificial intelligence has become such a hot topic. Let's talk about your background and your lab. What's new with AI? And I have some questions for you. How about that?
Okay, that sounds fantastic. Well, let's start with the lab because you see that I'm coming to you from Berkeley, from the University of California, Berkeley. And Berkeley is one of the great uh, uh, higher education institutions in the world, and it has a really great artificial intelligence lab. And it's interesting because it's a public AI lab. So here you see that we actually have 70 professors in the Berkeley AI Research, or BAIR, 70 professors, and they're in a wide range of fields that come under uh, the umbrella of AI, computer science, of course, and robotics, machine learning, computer vision, psychology, economics. And then we have over 400 PhD students, and many of whom are actually Chinese nationals, and thousands of undergrads. And they're working on the next breakthroughs in AI, and generally are drawn to this not only to advance the field, but to do good, do good for the public. So uh, we're top ranked in computer science in the world. And I personally work in a group called the Center for Human Compatible Artificial Intelligence, and we are concerned with making AI that is provably safe and beneficial for humanity. So, every day we read that generative AI is going to transform every functional area in every sector, and you know that AI is in fact integrated into every aspect of human life in one way or another. But uh, we're really only a couple of years into an experimental era of generative AI. It's just getting started. And the thing that I like to talk about before we get into how impactful AI is to talk about the phenomenon that is underneath it, right? Beneath AI, there is a digital, computing infrastructure that is itself interposed into nearly every human activity. And that is the global internet. So, even a couple of years ago, you can see in this picture, our activity creates digital data to the tune of 120 zettabytes per year. And that's an awful lot of zeros. That's 120 billion terabytes. And remember, you're lucky if your device has 1 terabyte, right? Um, and so the internet is I think the largest single technological creation of mankind, right? Interconnecting all of us and our devices and so on. And then um, as you think about all of this data generated, it it I think you should look at the next slide. All of this data is generated, and the firms that offer services are very centralized. So we have the data and the networking and the processing power infrastructure that has made possible these inventions um, of uh, neural networks, because you need to collect a huge amount of data to train a neural network. And And then the next great breakthrough was the embeddings and transformers that gave us the large language models, and they started around 2017. So generative AI owes its impact to the fact that we are living in a world of always on, ultra powerful, sensor rich, ubiquitous connected devices with highly centralized digital services. And this business of generative AI is the cherry on top.
Absolutely. So I think people are wondering how generative AI affect the world across different geographic regions, as well different businesses. So let's quickly go through the next few slides just to give people the perspective, and then I can ask you some questions. How about that?
Sure.
Okay, what's next?
So there are um, uh, there are certain aspects to the the advent of generative AI that it's worth understanding. Um, if you're going to make a computing system that is controlling something as powerful as a hydroelectric dam, then you'll need to apply um, the the typical engineering methodologies to it so that you can put bounds around its behavior. You can say you only should go so fast, and you should not exceed certain thresholds. And and it is a thrilling prospect that we could use something so smart, what seems seemingly smart, as a language model to control a hydroelectric dam. But the problem is that um, these models, these transformer models, consist really of a huge circuit that's like a mixing panel, but this mixing panel just has 1,000 knobs, but a mixing panel where there are really 1 trillion knobs, and each knob is adjusted as part of the training process. And so you feed some data in, and if you don't get the response that you're looking for on the output, you make an adjustment and you adjust the the trillion knobs a little bit so that you will get the right answer. And you do this about 1,000,000,000,000,000 times, and in the end, you get a circuit where all of the knobs have been adjusted, and that gives you the language models that we're now using, the CPT 4.0 and so forth. And these commercial models have a couple of qualities in common. One is that they're very powerful and they can do really surprising things, produce um, uh, quite uh, competent responses to many kinds of questions, and create images, and they're quite capable, across a very wide range of application areas. But one thing they also have in common is that they are not reliable. That is, you can't tell a language model, do not answer medical questions, right? It's simply, we build a layer around it that we call the sort of the safety layer, but it is very hard to get any sort of a guarantee around these things. And so that somewhat narrows the kinds of applications that they can be used for. And we're just 2 years really into the experimental era of generative AI. At the University of California, we have 10 campuses across the state of California. And we teach 250,000 students, and we have over the last 2 years embraced a strategy of promiscuous, deliberate, methodical experimentation with generative AI. And this thing is happening in many sectors and many companies throughout the economies here and in China and throughout the world. The early outcomes are interesting. Many tasks can be sped up, higher quality results, depending on the experience level of the user. Um, Management consultants can get 15% to 50% efficiency boosts, and coding, writing computer code. Some coders report that they can double their efficiency. But what's really interesting is that, and the reason that you see some of these estimates, there's such crazy promise economically, is that few tasks will see a really huge leap, like 100 times efficiency, when you think of applying in a very specific area. And I think you may want to cut this, but I'll say that I just learned that Sweden did a complete study across all of the sectors of their economy, and they found that the greatest efficiency boost from generative AI was in the application of generative AI to the process of doing some sort of architectural repairs. And you don't expect where it's going to make the big difference, but there are estimates of really of huge increases, and I think it really does have that potential, but it also does need to be taken with a grain of salt, because we really don't know whether we'll be able to tackle the issues of reliability.
So what's the miss of that? I mean, you're being a scientist and you're a practitioner and you're an educator. What is the most important essence or factor to determine the success of this transformation?
Well, I think there's the common theme to any major piece of automation, which is it's got to be suited to its purpose. And so if we just take generative AI and bring it to each and every aspect of what we're doing, we just need to make sure that what we would do without it is captured in the right way, so that when we implement it and that causes it to operate much more efficiently and more quickly, that we're not automating the bad parts of what we're doing manually. And so, this is where we, at the center, focus on the systems that could fail, and you want to design them in such a way that if there's a failure, you can trace back to the failure and then correct it to avoid the future repeat of that failure. And that's something we expect in any engineered system, like aircraft or nuclear power generation or a hydroelectric dam. But right now, generative AI is just beginning to see the beginnings of understanding how it operates. I'd love to talk a little bit about that if we have time.
I think I want to circle back about data and the feel for generative AI to work. So what's your advice to entrepreneurs who are not one of the, Magnificent Seven in the US or Baidu in China? What can they do to win in this transformation, in this race?
Well, the big digitals are providing the the tools for the next generation to apply. The field is still wide open for how you can apply these tools in each sector. So we are working with the UCSF Medical Center and have created a kind of variation on the transformer, and instead of training it on words, where you would really you're trying to capture the thinking, that's behind the writing that's trained with. We use the steps, the clinical steps for treating a patient, and so the training is on millions of sequences where a patient first presents with the symptom, and then there's a first test that's performed, and then possibly some medicine that's prescribed, and then some more tests and so forth. And that as training yields a completely different kind of transformer system that is much more legible. You can understand when it makes a suggestion, why it would make that suggestion. If it suggests a certain scan of the chest, it's probably because there's a problem with your lungs. And so that's a one kind of direction. And really it's a matter of again, suitability to purpose.
Let's go back to AI, and I do want to talk about the so-called reasoning. And I will share what Microsoft has just announced today on Yahoo Finance, talking about automation agents, and they use the word that AI can reason better. And they can perceive the environment in more sophisticated ways, so that, that means they can carry out more complicated set of tasks. We work together at Dark Matter Artificial Intelligence. One of the things we, really focus on is this, reasoning cognitive framework. What's your view on this, given what Microsoft is saying today? Are you optimistic that this is actually happening, or is still a black box that's not predictable?
Let's talk about reasoning.
Right.
What Nadella is talking about is that there was a real gap in the behaviors of the language models up till recently, where everyone would notice that it would just make nonsense suggestions. It would not, if you give it a fact, that Helen is David's mother, then it would not know the fact that David is Helen's son. It just did not do the reasoning quite right. And with significant training and some additional tuning to the architecture and so forth, it does manage to get a lot more right. However, we don't know where that will end. We don't, again, there's no guarantees. So I think what they're talking about is getting to a point where it achieves a useful level of reliability in certain tasks where that wasn't the case before. And I really don't know whether I would bet that that you can use these systems in high criticality tasks. I think just that small chance that a little variation in the request will give a big variation in the answer is makes it less reliable. So there's the jury is still out. There's a good reason for Microsoft to be claiming that it's coming and it's going to solve all of our problems, but there's also a good reason for us to be cautious. And I think there are testing methodologies and evaluations that are helpful, where you're as exhaustive as you can be with respect to testing. But it's again, it's a lot of promise, and the result remains to be seen.
Well, Mark, it's always fascinating having these conversations with you. I hope that we'll have opportunity to have you for a much longer forum or conversation or face-to-face. So thank you so much for taking the time. Thank you, Mark. Thank you so much.
Thanks for having me, Helen.